All right, I've got the top of the hour. So hello, everyone. Welcome to the fifth and final day of Samvera Connect 2020. My name is Heather Greer-Klein, and I am the Samvera Community Manager. I'm white with curly hair and glasses, and I'm wearing an I voted sticker, and my pronouns are she, her. I'm today's host, and I'm looking forward to guiding you through today's program. Samvera is dedicated to providing a welcoming and harassment-free community experience for everyone. Samvera was conceived and executed as a collaborative open source effort from its very beginning, committed to openness and transparency in all that it does, code, designs, and discussions. We are equally committed to helpful and respectful communication. The community has both an official code of conduct and an official anti-harassment policy. The code of conduct expresses our aspirations for how we want to work and interact. The anti-harassment policy provides a framework to deal effectively with issues that make any member of the community feel unsafe or threatened. The goal of the policy is to provide prompt and supportive assistance to anyone subject to any form of harassment. The policy is only one aspect of our broader desire to build a diverse and welcoming community that encourages participation and contribution from all participants without bias. If you see something missing, we invite your input to the policy and in making Samvera a better place. If you haven't already, please take time to review the documents today. We expect participants in all community events and forums to honor these standards. So building on the framework provided by our two policy documents, Samvera community members work together to create and promote a welcoming and safe community. If a situation arises that you feel you cannot address alone, please contact a member of this year's program committee, a member of steering, or a helper. We're all well positioned and prepared to assist you. Helpers are distinguished by a special rainbow symbol by their name in Slack, and helpers are volunteers who give their time to ensure that Samvera remains a safe space for open, collaborative work, both online and someday again at in-person events. So here's a list of the current helpers. You might want to take a screenshot of this slide for your reference. We've also put that information in the Connect channel of the Samvera Slack, and I'm sure we will also drop it into the Zoom chat. So you can find those helpers on Slack. Please direct message one or more of them if you have any question at all or any concern, especially if it has to do with our code of conduct or anti-harassment policy. If you see a helper on Zoom during a Connect session and you want to reach out, please feel free to use the private chat feature. And we have an email list that you can always use to reach out for help or information, and all of the helpers receive those messages. So more information about the helpers is on the wiki at the link noted here. If you want to become a helper, we welcome new volunteers for every Samvera conference, and it's a great way to serve and support our community. You can learn skills that extend into the rest of your life at work, at home, and out in the rest of the world. So here is our schedule for today. We have 5 presentations of half an hour each between 11 and 1:50 p.m. Eastern Daylight Time, and we're going to have 10-minute breaks at 12 p.m. and at 1:10 p.m. And with that, I'm going to stop sharing and hand things over to our first presenters, who are our friends from Notch 8.
Good morning. I think Kai's going to do our screen sharing, so we'll give him a second to get that going. Thank you. So I will start by introducing myself, and I'll let Kai say hi, and then we'll meet our interns in just a second. How about I turn my camera on as well? There we go, bright-eyed and bushy-tailed. So I'm Kevin Kochansky. I'm client liaison at Notch 8. And Kai, do you want to say hi?
Hi, I'm Kai Stroud, a developer at Notch 8.
So Notch 8 is, I'll get to introductions. Notch 8 and Learn Academy have an internship program that we partner on, and I'll tell you just a little bit about that as an introduction here. Notch 8 is a web development consultancy specializing in Ruby on Rails, and we were founded in 2007 by Rob Kaufman. In 2016, as many of you know, we entered the Samvera space, so we've been pretty active here and enjoyed interacting with a lot of the folks on this call over the several years. In 2015, Notch8, the founders of Notch8 co-founded Learn Academy. So Learn Academy is a web development bootcamp based here in San Diego. This year they've gone 100% remote, so anybody around the country could actually enroll in Learn Academy, and it's been very successful doing that. And an important part of that program is the internship. So it's a 16-week program, and the last 4 weeks of the program after the classroom instruction or virtual classroom instruction is a 1-month internship. There's a lot of local community partners that will take interns from Learn. I went to Learn Academy and I had an internship as well. But Notch8 very often will take some interns from their sister company. So this year we were lucky to get 3 really talented interns. We handpicked them, we get first choice, and we get to pick the best. And we decided for the first time ever to put Learn Academy students who are brand new to coding, just starting their careers, onto a Samvera project. So we thought that giving a little presentation here to introduce that and tell a story about how that went might be of interest to the folks in the community. The project that we chose to put them on was the bulk racks gem that Notch8 put together for Haiku and Hyrax for bulk import and bulk export. And I will pass it on to Kai to tell you a little bit more about why we chose that project.
So for a little bit of context, I kind of served as the project manager for this round of interns. The reason that we picked bulk racks was that the immediate needs for the project that we had in mind were not super deep into the Hyrax or Samvera in general stack. And so there wasn't a ton of overhead knowledge that was absolutely necessary to be productive and to see progress being made. Another good reason to pick it was there was a good payoff because the interns could see their work in action, and their work would go into all kinds of different projects. Everyone who currently uses the bulk racks gem and would have a much easier way of getting the work out there to actually get good use. It also incorporates the intern experience with a lot of the Notch8 team. Over the years, Notch8 has had more and more people working on Samvera projects, and so a lot of knowledge for that software has incorporated its way into the Notch8 team, and so lots of people are able to provide feedback and help when they had questions. And also it was open source, which again kind of feeds back into the being able to see your code get good use and get out into a community that lots of people can see it and use it and get some use out of it. So we keep talking about the interns. Some of them are actually able to make it to this talk and were kind enough to participate. So we're actually going to go into introductions for them. April, Jeremy, and Ruben. Let's start with April. Can you please introduce yourself?
Hey everybody, thanks for the warm introduction, Kai. My name is April Rieger. I am a white female in my late 30s with curly brown hair. A couple of my strengths were that I have a background in graphic and web design with front-end languages, and some of my goals for this internship was to create a feature for my portfolio, as well as contribute back to open source and give back to the community at the same time.
Thanks. And Jeremy.
Hi guys, I'm Jeremy, early 30s, Filipino. Going into Learn Academy, one of my strengths was coming from project management, and going into the internship, one of my main goals was to contribute to open source, which fortunately I was able to, and also work with other developers via an agile process. So thanks to working within Notch8, I was able to experience that firsthand.
Thank you. This is Kevin again, and I did neglect to describe myself. So I'm a white male in his mid-40s with a closely cropped, some might say bald head. And our third intern, who was equally stellar but wasn't able to join us today, was Ruben. And some of his goals for the internship were to work on a project that he'd be able to feature in his portfolio and to just really take advantage of that time to ask questions and make the most of his learning experience. So I want to ask a couple questions of our interns that are able to join us about what it was like to jump into Samvera. And my first one is going to be, what was your introduction to the Samvera community like? And let's start with April.
Yeah, I think it was the first week, Kevin, of our internship. You invited us to the haiku interest group, and it was so great to hear some of this Samvera technology, as well as hear the community and having the universities and scholars the ability to access the digital collections, and also like tying back in and making my contribution a little bit more meaningful. So it was really amazing.
Thank you. How about you, Jeremy?
Yeah, everything that April said, but in terms of technical side, coming as a junior developer, freshly out of coursework, the code base was really huge, and understanding the architecture was definitely above my pay grade at the time. So hearing terms like Solar, Fedora, Hydra, things like that, I had no idea. But fortunately, I was able to understand that we were just working in the realm of bulk racks. So that helped me quantify it a lot better going forward.
Maybe you can continue on that, Jeremy, for our next question, which is, what would you say were some of the struggles of jumping into the more technical side of Samvera?
Like I said, at least in my opinion, looking at the code was huge. But then one of the first things I noticed while jumping into these tickets was, I think some of the dependencies or things used seemed like it was using older versions. So finding documentation to help me build upon that was more difficult just because the versions were older. On top of that, it was using Ruby on Rails, which was something I wasn't super comfortable with going into the internship.
Okay, how about April?
Yeah, just to piggyback off of what Jeremy said, yeah, the documentation for all of the gems or the dependencies that we used were out of date. So there was one issue where we had to incorporate some of the Bootstrap into it, and we were using Bootstrap 4, and none of the styling was working. And we were just hitting our heads against the wall. And then finally Kai had told us, like, yeah, we use a later version of Bootstrap. So that was kind of fun. But like, as you all know, there's many layers and connections in these applications that use the Samvera technology. So it's a bit overwhelming at first. So, but it's nice to have the community as well as Notch 8 there to hold our hand and walk us through it.
Well, thanks both of you. I will pass it to Kai to tell us a little bit more about the work that was done on the internship.
Thanks. So like I kind of touched on a bit earlier, a lot of the project this time around was UI focused. And so we'll jump into some of the specifics for that. Namely, a lot of the views that Bulkrax uses had very data heavy fields, like the parser fields and the field mapping. A lot of it is just key values that are mapped out in HTML and really difficult to look at when you're just trying to skim through and find a particular field. And so we wanted to make those fields a little nicer to look at, a little easier to get a quick glance and find out what you're looking at. As well as on the importer show page, the collection entries and work entries tables. The columns weren't aligned. If you look at the status and errors columns, they weren't aligned between the two tables, which again just kind of makes quickly glancing at the table to find out whether something failed or not, what its status is, just that much harder. And so we wanted to kind of hammer out some of those finer details to make it a much better user experience. Likewise for the entry pages, not border pages, those also had some pretty data heavy fields. Specific to these pages, some of the entry pages, if an entry errored, it would contain error information for why it errored, so that the user using the system can come in, see what went wrong so that they can help hopefully rectify it, or send the error information to their dev team so that they can take a look at it. And in particular, we wanted to include the error trace on the page itself, which again would just make troubleshooting that much easier instead of having to dig through server logs. But in reality, it just ended up being a huge block of text that wasn't really that helpful for troubleshooting. It was at that point just easier to go and troubleshoot elsewhere. And so we wanted to, again, kind of make those easier to look at, more useful to the user, and the like. Other than strictly view-related changes, there were also some bugs that we wanted to hammer out. For example, there was one where if you were trying to split a multi-value field, usually these happen on semicolon, but for the pipe character, which is a different option to split, for that character specifically, it would not trim the white space around it. So looking at the pipe, at the top, there's white space between the URLs, and then at the bottom, the parsed out field, it's split into two different values, but on the end of the first one and the beginning of the second one, there's white space. And for controlled fields, this would actually cause issues because those have to be exact matches for dropdowns to work, for example. So those were some of the bigger pieces that we had goals for. And so we're actually going to jump into a demo of some of the work that was done. And April is actually going to take us through that.
Awesome, thanks, Kai. So here on the show importer page, I just wanted to call out that we replaced those toggles with accordions using small design interactions on click that Jeremy created. And we created a more interactive and engaging experience for our users. And then we also included the bolding of the key values to differentiate between the title and the content. We also added syntax highlighting to the field mapping field, which is very data heavy, and it makes it a little bit easier to look at. We were also able to provide users with the ability to alternate between that full and that raw markup language for the field mapping in order to send the markup language over to the developer. We also created a visual solution for the misalignment in the columns through the addition of the tabbed view for our work entries and our collection entries. And we did all this while making sure that the design matched the original and existing design of Haiku. And then if we could go over to the show entry page, I just wanted to point out the error tracing. So this is the example of the error trace with the ability to alternate again between the full and the raw markup language, just to help ensure users can quickly identify the error or to troubleshoot for themselves or send it off to the developer.
Awesome. Thanks, April. So now we're going to move into some of the takeaways that April and Jeremy had from the internship. We have a couple more questions for them. The first one being, what was it like working in an open source stack? Let's toss this one to Jeremy first.
Thanks. Before jumping officially into web development, I knew of open source software and code, but never really knew how it actually happened. So through this internship, it was kind of an eye-opening experience to understand how people contribute exactly to open source. For example, guidelines they have to follow, making the PR requests and waiting for it to get approved, things like that.
And April.
Yeah, being able to work on this open source project allowed us the ability to learn and grow in a very friendly atmosphere. Being able to tap into the Slack group, search around for questions, because I wasn't too comfortable asking just yet, but now I am. Very friendly community, so thank you so much. And it's so rewarding at the same time to work on something that the community could also use.
Thank you both. And our last question for you both was, has your experience working with Samvera affected your goals as a developer? And if so, how? Let's start with April.
Thanks, Kai. Working with Samvera, as well as with Notch 8, has provided me the ability to apply the knowledge that we gained at Learn to real life applications, as well as accomplishing the goals that I set out for myself during the internship. So it's pretty amazing.
For me, working immediately with Samvera was a great way to see how engaged and selfless the development community really is. So that basically has encouraged me to continue contributing to open source where I can throughout my new, lifelong career in web development.
thank you. I will definitely open to questions if folks want to enter the QA. We do have plenty of time if anybody has anything to discuss, but this could also be a perfect time for a morning coffee break. But before folks tune out, I really want to thank our interns. Taking interns is just part of Not Shate's culture. We like to mentor, we like to disseminate knowledge and just help contribute to the community, and that's really speaks to what drew us to the Samvera community in the first place. So it was just really great convergence of things to be able to bring interns into a Samvera project a little bit. And April and Jeremy and Ruben were all just really great. And I'm just happy to share here that April started full time as a Not Yet developer this week. So we're very happy to have her. Love to bring on more interns full time, but you have to pick when the skill set is a perfect match to what we need. So we're really grateful. And I want to thank Kai also for helping out with this. I know you're a bit under the weather, but I really appreciate you taking on this presentation this morning. Let's see, are there any questions?
Yeah, Kevin, there was a question in Slack for April and Jeremy. And April, you touched on this a bit, but maybe each of you could go into this in a little more detail. It was, did you ever ask questions on the Samvera Slack channels or on the message board? And if so, how did that go?
So for me, I did find the Slack channel and it was an amazing resource. I didn't quite feel comfortable yet talking or asking questions within, but it was really nice to be able to search through it and see if any of my questions had already been asked and to try to take a look there, as well as you guys have a really extensive board with the wiki page and all the images that you guys have. So it was very nice to have those resources, but I do now feel comfortable asking questions. And I think I threw my hat in the ring for the UI development of this Samvera product. So I'm excited to get on that team and help out.
Awesome. Be happy to have you there.
Another question from Emily in the QA interface. How much influence do you have, and I guess this is for Not-Shate, how much influence do you have over what's studied through Learn Academy? And can you help provide more Rails experience, for example? I'm going to give you the Not-Shate side, but then I would actually love to hear from the interns about how they felt the Rails experience was. The curriculum, the initial curriculum, 5 years ago was co-developed by the founders of Not-Shate and the leaders at Learn Academy. And they regularly, at least monthly, if not more, reevaluate that curriculum and change it. I was in the program myself 2 years ago, and they made midstream changes to respond to the difference in demand of today's tech scene and what jobs are available in the community. And they really continually reevaluate and sculpt that curriculum to make sure that it remains relevant and that we produce, or that they produce, employable developers. So it's founded on Ruby on Rails and React, and Ruby on Rails continues to be the kind of back end core of that curriculum. But maybe April or Jeremy would like to talk about the level of experience there and how you think how equipped you feel.
I feel like what Learn provided in terms of Ruby on Rails is definitely sufficient. It definitely provided fundamentals moving forward for different backend languages. So understanding how Ruby can relate to Python, for example, Learn has definitely set that foundation, and I appreciate that.
Yeah, for me, I already kind of had that front end development, like CSS, HTML side, all the design basics. So I really dove into the Ruby and the Ruby on the Rails and more JavaScript and React.js. And I think they really equipped us with the ability to see those connections, whether it's through the tables or any of the Rails or the Ruby connections through the Samvera and the hierarchs. So it was really easy to kind of pick up on those and the connections. And yeah, it was really good.
Thanks. Any other questions? In the meantime, I also want to make sure that folks know that they can register for their free Connect 2020 swag bag. Not Jade is just going to send things out because we missed being at a conference this year too. So we're happy to send a little goodie bag to anybody that signs up for one. That's at haikuup.com/swag. Well, if there aren't any other questions, I just want to say thanks again. And I really appreciate the opportunity to share this experience at Connect. And we'll pass it back to Heather. Thank you.
Thank you, Kevin and Kai, and April and Jeremy. We're thrilled to have you. There was some chatter in the chat about how great your changes look. We want to keep to our schedule. So right now we're going to take a 5-minute break and we will return with Lynette's presentation at exactly half after the hour. So 11:30 a.m. Eastern Daylight Time. All right, we're back with a presentation and I'll hand things over to Lynette.
Hello, I am Lynette Rail from Cornell University. I'm a Ruby developer and have been a core developer for the Samvera community for the past 6 years. I work heavily on questioning authority and hierarchs. So I'm going to start my talk a little bit different today. I usually start with all the details and then move toward a summary, but I'm going to go in reverse order because I have a lot of details and I'm not sure I'm going to be able to get through them all. So after the summary, I will go back and do some of the details and we'll just go until I run out of time. So hopefully from this though, you will get a sense of where things are in our drive to enter Hierarchs Hala. So call went out earlier this year to have organizations try and remove Active Fedora from their apps and to refactor those to use hierarchs replacement calls and the hierarchs wings adapter, which uses Valkyrie to persist to Fedora through Active Fedora. So our ultimate goal is to use Valkyrie Postgres adapter with our hierarchs apps. So when I was looking at this, I went a few steps further than might have been called for. And I used our USDA ESMIS site, which is currently on the latest release of the Hierarchs 2 series. And I'm using this as the test platform to sort of migrate our Active Fedora objects to be Valkyrie resources and then see what works and what doesn't work, and to fix the whatever issues come up along the way in Hierarchs. So I've been steadily working my way through the code migration process. As you can see from the chart, the first step was to create Valkyrie resource versions of the work models. And that's actually working pretty solid. So that's why it's all green. And the second part is migrating the indexing, which is also going really well. There are 2 issues that are outstanding at this point, but neither of them are blockers for continuing to move forward with the work. And most recently, I've started working with the using the new form in order to actually create the Active Fedora resources from a form in Hierarchs. And this is going pretty well. I ran into some problems in my code, but I don't think it's actually on the Hierarchs end. I think it's some customizations that we have that are clashing with it. I removed most of the customizations, but I think I missed a few. So everything looks like it's working in when you do it in Hierarchs. So that's why I think it's actually doing pretty well. But I do need to dig a little deeper into how sharing is doing and how relationships are doing before I would mark them green. One of the things that happens when you finish the form is it automatically forwards to the work display page. And that forwarding is happening, but when it tries to bring up the display page, it actually raises an exception. And so this is kind of like the place that is the blocker at the moment to resolve that. So you'll see that the rest of it doesn't have any color coding yet, and that's because that hasn't been evaluated. This is mostly things like presenters, search builders, and migrating the other Active Fedora objects like collections and file sets. So that looks like a lot of work, but I would say that a lot of this has already happened in Hierarchs. And so it's more a matter of just making my application use those things. So it's not really starting from scratch. And then there's a section of Active Fedora references in my application. And I'm not too worried about those either, because those same kind of references have already been refactored in Hierarchs. So I should be able to follow the exact same patterns in my app. And there are 3 that are in initializers. So that might be a little bit more tricky, but there's only 3 of them. So I'm sure it'll come through pretty well. And at that point, I'll be ready to actually do the test of seeing, can I read my currently existing Active Fedora data using the new Valkyrie resources? And once I can tick that one off, then I can start the actual migration process, which would be to use the Wings Active Fedora adapter to read in the data, and then use the Postgres Valkyrie adapter to write out to Postgres. And that'll be when we really see just exactly where are we with this whole process. So that was a lot of information, but it really only tells part of the story. I've been documenting the process as I go. And so this has a link to that documentation. And there you'll get more of the details and even some like steps that you could follow if you wanted to try and do this yourself. And one other place I wanted to kind of point you from a documentation perspective is there's a dive into Valkyrie tutorial that's in the Valkyrie GitHub wiki. And this covers the basics of Valkyrie. So if you haven't looked at Valkyrie at all really yet, this is a great starting point to just sort of get your mind around some of the concepts. And it has some actual hands-on things that you can do to try it out yourself. So when I proposed the presentation, I said I would try to have some benchmarks. I'm not really at a point where I could do like a full-fledged benchmark analysis, but I did do some quick and dirty performance tests. So one of the things that makes it quick and dirty is that I just did simple atomic tests. So on the right, you can actually see what I did to do the create tests and what I did to do save and what I did to do read. And I did it from 4 perspectives: what it's like in Active Fedora, what it's like with the Wings adapter, what it's like with the in-memory adapter, which should be blazingly fast, right? Because it's all in memory. And then what is it like to do it with Postgres? And so you'll see that the Wings adapter is pretty slow on the save. I basically think this is due to the fact that the way the save works for Wings is that you convert the Valkyrie object into an Active Fedora object, and then the Active Fedora object is saved. And then when you want to read it in, you do the opposite process where you read in the Active Fedora object, convert it to a resource, and then you operate on it as a resource. So what we think is happening is that in that save process, it's actually doing that transformation like multiple times. The link at the bottom is a link to that documentation that I created on our process. And this is the one specific to performance analysis. And at the bottom of that page are some links to the full profiler run for the Active Fedora save and the Wings save. And so we'll be looking at that to see where actually are these transformations happening, where are they being called from, to see if we can tighten that up, because it really shouldn't be that much slower than doing it through Active Fedora. So I will say though that these numbers it doesn't bother me too much, because our ultimate goal is to be in Postgres, and all the Postgres numbers really look excellent. So I want to put in a plug for the Developers Congress at this point, because if this is work that you are really interested in seeing move forward, the issues that have been coming up, I've been collecting them together, and at the Developers Congress, we will try and work through those issues so that we can continue to push this work forward. So that link on this page is taking you to the Developer Congress page in the wiki, and you can sign up and express an interest and all sorts of other good things and find out when it's going to happen and how to get involved. So I thought the next best place to start is to looking at how things are different between Active Fedora and Valkyrie. So the place we're going to start is, what does it look like to do persistence? So to do persistence in Active Fedora, you just basically call save on the object. To do persistence in Valkyrie, you pass the resource to a persister. So part of the reason for doing that is that you can actually pass that exact same resource to multiple persisters to put it into different data stores. And that's greatly going to help with the migration process, because as I said earlier, our migration process is basically going to be to read it in with the Wings persister, Wings adapter, and then to write it out with the Postgres adapter. So one of the things that happens when you save in Active Fedora is it does both a write to Fedora and a write out to Solar. So when you call the Valkyrie save, it's only going to write to the data store. So in this case for Wings, that's going to be a write out to Fedora. But we do want to get the indexing happening. So how are the indexing in Active Fedora and Valkyrie different? So as I said before, Active Fedora, you just call save on the work and it's going to get written out to Solar. For Valkyrie, you're going to call save on the index adapter, and following a similar pattern to the persister, you're going to pass in the resource. And that's what's going to do the write out to Solr. So that active Fedora save is writing both to Fedora and to Solr, whereas the index adapter is just writing, it's going to generate that Solr document and just write it out to Solr. So understanding a little bit about the difference in the sort of process of when you want to modify an object. In active Fedora, you want to modify an object, you just write on the object, say work object.title equals my new title. In Valkyrie, the standard way of doing that is to create a change set, and then you make the change in the change set, and then you sync it back to the resource. So you can actually write directly to a resource, but using a change set gives you two advantages. One is that you can make multiple changes to the resource in the change set before you persist. And then you can check and see, is this a valid change set? And if all the validations pass, then do the persisting. If they don't pass, you don't have to worry about backing anything out because you haven't changed the resource at this point. So to sort of look at the full process, for active Fedora, you would make the change and then you would call save. For Valkyrie, you create the change set, you make the change in the change set, you sync it to the resource, then you pass that resource to the persister to save it in your data store, and you pass that resource to the index adapter to save it in Solr. So that looks like a lot, but fear not, because we have transactions in Hyrax. So the actual process in Hyrax looks more like create the change set, make your changes in the change set, and then call the update work transaction. And what that's going to do for you is it's actually going to do multiple steps in that transaction. It's going to set the modify date, it's going to set the upload date, it's going to validate the change set, it's going to sync the change set to the resource, save it, and then it's going to call Hyrax publisher publish, passing that it wants to publish the object metadata updated. And what that does is it's going to call the indexer and then save it to Solr. So this transaction is, roughly speaking, a replacement for the actor stack that would have done this same set of processes. I will say that having worked with transactions now, I am really liking this pattern because every step is nicely isolated out and easy to follow, and you can tell exactly what's going on at any point in time. So the last part I'm going to talk about in understanding the differences is the difference between querying active Fedora versus querying Valkyrie. So the most basic type of query that we do all over the place is I've got the ID and I want to get the object for it. So for active Fedora, you call active Fedora base find and you pass in the work ID. For Valkyrie, it's pretty similar. You're going to do the Hyrax query service find by, and you're going to pass in the work ID. So there are many ways to actually do querying of active Fedora. It's not just the find. You frequently have ways to call it in such that it searches Solr and it returns an object from Fedora. Also, a really common way to create customized ways of querying the Solr is using search builders. So Valkyrie does all of its searching through the query service. So there's a standard set of methods that are already predefined in the query service. And then if you want to extend that to other things, you define a custom query. And that custom query is the major way of extending the Valkyrie's ability to search. But even the custom queries are going to go through the query service in order to do that search. All right, so that actually brings us to the migration process. And just for a little background, I'm going to describe what our models look like because I'm going to be referring to these models quite a bit in the examples. So we have a pretty simple model. It's not particularly complex. At the collection level, we refer to those as agencies. And then you can have two work types. We have a publication work type and a release work type. So you can have many publications in an agency, and you can have many releases in a publication. Our publications don't have files, but our releases can have many files. So our release and publication are pretty tightly coupled. So when you actually look at the publication in the UI, you can get direct access to the files right from there. But that's not really going to play into what we're going to talk about here. So I won't go any deeper into that. This is what our active Fedora base model looks like for the publication. And I will tell you, this isn't even all of it. I had to cut some of it off because I couldn't fit it on there. And don't even try to read it. The point is just to see that there's a lot of stuff in the active Fedora base model. But they all break down into sort of like 3 major components. There's the property definitions that define the metadata. There's the validations that confirms that everything in the model is correct. And then there's some helper methods that we put in. This is our custom code for the helper methods. And that's primarily used for navigation and maintaining that model structure I showed. All of those are actually going to move to different places. So we'll take a look at where those places are as we move through. But the first step you're going to do when you want to create a Valkyrie resource model is to generate the work resource. And just like we had a generator for the active Fedora works we would create, we also have one for the Valkyrie resources. So you just call Rails generate hierarchs work resource and you pass in the name. And that is going to generate a whole bunch of files. And the kinds of things that were actually generated are the controller, the metadata YAML. The metadata YAML is where you're going to define what kind of attributes you want in the model. And then the model resource itself, the indexer, a form, and a view. And a good part of those have specs that are generated for them as well. So the generated resource, this is it. This is what the generated resource looks like. And I will tell you the final version is going to look very similar. So the thing I want to bring your attention to here is these 2 include statements. The schema loader will take the metadata YAML file that we're going to look at in a minute, and it will use that in order to generate the attribute statements that define the attributes for the resource. The hierarchs work has a similar statement in it for the core metadata. And here in the work, in my work, I'm including in the basic metadata and my publication resource. So this is the final version. That's all there is. So that big, massive thing we looked at a minute ago all boils down to this. The include publication extras is using a module include in order to handle the extra custom methods that we have. This may not be the ideal thing. It may be better to put them into services, but for right now, as I move through the process, this was the easiest path to continue moving forward. So how do we define the metadata attributes? So again, this is what the active Fedora model looked like. And what I've got highlighted here is all the property statements in that model. And this is what an individual property statement looks like. And you can see that the key parts are that it has the property name. It defines whether or not this resource, this particular property is can have multiple values. How do you want to index it? And what predicate do you want to use? And so this is telling us which file it wants to come in. So this is our resource model again, and it's saying we want to do publication resource. So I will tell you that that publication resource YAML file is generated as part of the generator. And you can pass in attributes and it would generate some of the attribute statements for you too. But I didn't in my case because I had a lot of attributes to bring in. And so I just decided I would do them by hand. So it starts out with the attributes being empty. But this is what an actual attribute, the same one that equates to the property we were looking at a minute ago, this is what it looks like. And so what this is going to do by saying this is multiple value and that the type is string, it's going to define the attribute with the name isNy, and then it's going to say the type is an array of strings. The index keys are going to determine what gets indexed automatically. So you won't have to do any kind of indexing to get the isNy TESM key in there. And the form configurations are going to determine how these things interact on the form that gets generated. So again, the form, the new and edit form are going to be generated for this based on what those values are in this metadata YAML file. This is actually really nice because you see all the values in one place. You easily see how the values are being handled. And so updating and following through this is actually pretty easy. So one of the things that's not covered by doing a direct property to attribute type migration is any kind of relationship that you define using directly contains or indirectly contains. There's not a direct equivalent of this in Valkyrie. So what you do is you define it as an ID. So in this case, we used to have an indirectly contains member of publication. Now I define this in that metadata YAML file using publication ID, and I just define it with the same kinds of definitions that we used previously. The thing that happens here, this is a single value for me. So this is going to have a type of ID and multiple faults, and it will produce the attribute definition saying it needs to be a Valkyrie ID. So then I want to handle all this extra custom code that we had in our Active Fedora model. And that, again, is where we bring it in using the publication extras. This is just a standard module include. There's nothing fancy there. The types of extra code that we have in our customizations are navigation methods. So if I'm at if I'm in a publication, how can I get its collection? If I'm in a publication, how do I get its child resources? And if I'm in the release, the child releases, if I'm in the release, how do I get the publication from the release? And also, we use it to maintain the relationships between the models. So if you add a publication to a collection, you can add or remove it directly from the publication resource. And the same with the release, you can add or remove it from a publication. And then the other thing we use it for is we have an identifier that holds a slug that is unique across all of our publications. And so I implemented a custom query that allows you to find a publication given its slug instead of its ID. And so this is how we basically handled it. So for navigation methods, those were converted to Valkyrie custom queries. And maintaining relationships between models, I do that through Valkyrie change sets. And basically the reason I do that is because when I want to set the publication for a release, I'm having to change, especially if it's a move, I actually have to change 3 things. I have to change the old publication, the new publication, and the release. And so I do all of those in change sets. Then I validate all 3 of them together before I do the save. So that allows me to make sure that the change is going to go through before I actually commit anything as a save to any of the objects. And then the last one I already talked about was the publication by identifier field. And for that, I also used a custom query. So the other main thing that you're going to need to do is migrate your custom indexing that you did in Active Fedora. So in Active Fedora, you use the generate solar document method. And in Valkyrie, we're using the toSolar method. So this is what the indexer looks like when it's generated. You will see that it has similar kind of includes where this is again getting data out of the metadata YAML file and using that to know what kinds of indexing fields should it create. So it's going to do everything from basic metadata and release resource for you automatically, so you don't have to define those fields. And that's actually similar. We had something similar in Active Fedora, so that's not a really different pattern. So this is what it looked like in Active Fedora. Don't bother reading it. What I'm going to tell you is this generate solar document almost exactly matches to the toSolar. The only difference is that because I moved the publication ID, I don't need to do that now. It's going to get picked up automatically from the release resource being indexed. So the next part of the migration process was to explore forms and how the works display. So there is a form class that gets generated for you. And again, I didn't highlight it this time, but you can see it has the same pattern at the top there with the includes. The form fields are going to be based off of what gets defined in that form section of the metadata YAML file. So what's working in forms right now that I have confirmed is working. So the form view gets generated as expected from the metadata YAML file. The required fields are marked as required. The primary fields show up above the fold. So there's, for those who aren't familiar, there's a button at the bottom that says show more attributes. So if it's primary, it's on that first screen. And if it's not primary, it shows up when you click that button. And then also anything that's marked as multi-valued will have a multi-valued link that allows you to add more values. So I didn't point this out, but you can actually have the form be single value and the attribute as it gets stored in Valkyrie be multi-valued. And that definitely is something that's a pattern that can be useful. So it sets when you go into the form, you can set the fields, you can upload files. As I mentioned before, I had a little bit of problems with sharing with users and setting relationships, but again, that might be in my customization and not in Hierarchs itself. I just can't say either way because I haven't really clarified that yet. So the last thing that happens is after the form is saved, it tries to display the work in Hierarchs. And right now, there's an exception that gets thrown. We're going to be exploring that more to see what's up with that. And that kind of leads me, I actually made it through all my slides, so I'm surprised I had enough time. So this is where I am in my process so far, and I would make a call again for you to come join us at the upcoming Developers Congress, and you can take on some of these issues that I've raised and help us move it farther towards completion. All right, thank you.
Fantastic. And there's links to more information about the Developer Congress in the Zoom chat and in the Slack Connect channel. And Lynette, I saw two questions. One was if you have made your wonderful spreadsheet that everyone is very excited about, if that's available anywhere.
Currently, it's only on my machine in an Excel document, but I will be happy to put it out into like a Google Doc so that you guys can have it there.
Great. And then we have a question in the Q&A. A new version of QA has HTTPS instead of HTTP to LOC. This caused problems with already running Hierarchs 2.5.1. Could you please possibly add this against Hierarchs notes? We found this a tricky one until we found what the issue was.
Yeah, excellent. That's fine. And in the documentation I have, there is a page that is like stumbling blocks and gotchas, and it lists off all the issues that I know about so far, and that can definitely be added in there. If there's an open issue, if you can send me the link to the issue, I can point to that so people get more information.
Great. And if anybody else has any questions, we've got 3 minutes for questions. We've got a question, is the metadata.yaml format documented somewhere?
So in the file itself, I don't know if I can go back to it. Yeah, there we go. In the file itself, it actually has some documentation at the top. So this is what gets generated, and it has this documentation block at the top that tells you what kind of things it's looking for. In my documentation that I created, it actually sort of describes what each of these fields do and how you would want to use it.
All right, excuse me, one last call for questions. Seeing not, yes, thank you very much. That was great. All right, it is now time for us to take a 10-minute break. Let me bring this up. It's time for a little intermission, so we will be back here in 10 minutes at 10 after the hour, 12:10 p.m. Eastern Daylight. All right, welcome back, everyone. Our next presenters are Chris and Francisco from Ubiquity Press.
Hello. Can you hear me fine?
Yes, I can.
Brilliant. Thank you. So good morning or afternoon, depending on where you are. My name is Francesco De Virgilio, and I'm a white male with a mustache in my 30s, calling from London, UK. And I'm the CTO at Ubiquity Press. I'm here with my colleague, Chris Colbert, who's one of our software developers at Ubiquity working on repositories, and is connected from Indiana. With Chris today, we will try to illustrate some of the challenges that we had to overcome at Ubiquity Press when we started to serve Haiku repositories as a hosted service in Kubernetes in 2018. I will present the first part dealing with the Kubernetes and DevOps, and then I will hand over the presentation to Chris for the second part about customizing Haiku with plugins. So next slide, please, Chris. Thank you. So our CEO, Brian Hall, has presented the company a bit in a panel yesterday. So this talk will be very focused on DevOps and the Kubernetes side of things rather than anything else. So we currently run hosted repositories for a few different institutions around the world. We have a couple of screenshots from our repository for the British Library and for Pacific University. As you can see in the screenshot, these repositories look very different from the standard Haiku frontend. And in fact, we run our own frontend application on top of Haiku. And next slide, please. So before we go too deep into Kubernetes, I think it's worth highlighting what are the components that we run in our hosted repository that are not part of the standard Samvera stack. Over the last couple of years, we have built a REST API for Haiku that is used by the front-end application to fetch information about the Haiku tenant and it works. We've also built a custom Python service called the repo importer that mirrors the Fedora binary objects on an S3 bucket to make the downloads more efficient. And basically, every time a user downloads a file from one of our repositories, the file is actually distributed through AWS S3 bucket. So with this slide, I'm trying to clean the scene and trying to create a separation between the standard Haiku Samvera components and the components that we created and we run beyond that. Next slide. So I'm not going to spend much time illustrating the different components Haiku is made of. Tom Johnson on Tuesday gave a great presentation on running hierarchs in a cloud environment. But as of 2020, I think it's quite clear that there is a lot of conversation going on around hosting strategies and the architecture of the Samvera stack in the cloud. So I've listed a few here in this slide, a few resources on the web that show some progress in this conversation. One of these resources is a GitHub pull request that has some details on running hierarchs in Kubernetes with an Helm chart. And there is a very interesting architecture review document from Ratin Sundar from the British Library, which has been uploaded to the British Library repository as well. Next slide. Let's dig a bit deeper into Kubernetes since we have a lot of ground to cover. And in this diagram, I try to associate every component behind the Haiku application to a specific challenge. So the boxes are color coded. The red boxes represent the Haiku components, while the blue boxes represent other components that are specific to our setup. So if you follow the arrows, anyone with some experience of the Samvera stack will I think this will be pretty obvious to someone who's been running the Samvera stack in the past. But Haiku, the Sidekick workers, Solar, and Redis as a caching engine, they will all be facing the challenge of scaling. Fedora Commons and Solar, they will be facing the challenge of storage. And with regard to our own components, SSL is one of the components that basically had to be automated, and automation was part of the challenge there. So on the next slide, we see how we try to solve these challenges in the cloud environment, opting for Google Cloud and JKE, the Google Kubernetes Engine. Storage is provided by Google Cloud Storage for non-public files and binaries, and Google SQL is used for Postgres hosting. Scaling is achieved by a combination of the scaling tools offered by Kubernetes pods and Helm charts. And we'll see these in more detail in a few slides. Automation for SSL is achieved by using an open source application called Traffic that acts as a load balancer and as a reverse proxy. And Traffic basically automates the creation and renewal of SSL certificates through Let's Encrypt, and they are automatically rotated every 3 months. We have also written an Helm chart for the components in the red boxes, but unsurprisingly, we rely on the existing Helm chart provided by the community for the components in the orange boxes. So this is to say that basically we use the community Helm chart for Solar and Redis. They are very efficient and very effective, at least in our setup. Next slide. So let's dig even deeper into this. One of the ways of looking at the different challenges is to use the 12-factor methodology proposed by Heroku and endorsed by Cloud Foundry. I think that Tom Johnson has also mentioned these at some point in his presentation a couple of days ago. Not all of the points in the 12-factor methodology are relevant to our IT setup, so I have removed some of them. So we'll only see a few of them today. Next slide. So the first group is factors 3 and 10, configuration and parity of the development and production environment. So we run a test environment that is a perfect clone of the production environment, and all the differences between the two environments are encapsulated into configuration files. So these files are structured as YAML files. They are environment specific, and this is to say that there is one YAML file with all the configuration for the test environment and one other YAML file with all the configuration for the production environment. The YAML file is then used to render a Kubernetes config map, and this Kubernetes config map is then included in the Helm release when the repository application is installed through Helm. So the YAML configuration is injected into the Helm chart at the installation time, not at the build time. So this means that the chart that we build in the CI pipeline is completely independent from any specific configuration, and the configuration is only given at installation time through a YAML file. A couple of challenges that we have to face when running Helm in a production environment are basically the upgrade from Helm 2 to Helm 3 that proved to be trickier than expected, I think. And when we started running Haiku in Kubernetes, it was late 2017, I think, and we were running around Kubernetes 1.11. In the meantime, so in the last couple of years, we had to upgrade through all the versions of Kubernetes up until 1.16, and that meant that we had to use an Helm plugin called MapKube APIs to fix the Helm releases, incorporating some deprecated Kubernetes APIs. This happens when the version of Kubernetes changed, and these was also quite tricky. So I think that was worth pointing out. Next slide. The second group of, the next point on the 12-factor application are numbers 4 and 7, baking services and post-binding. So as we have seen in the previous slide, there are two entry points for the user to the repository, our front-end application and the standard Haiku admin interface. This diagram tries to illustrate how backend and frontend are completely decoupled. The decoupling is so deep that they even run in different Kubernetes clusters. Each cluster has a Traffic instance acting as a load balancer and as an SSL termination point. The front end communicates with the API through plain HTTPS requests, and this decoupling allows the front end and the back end to be deployed as completely independent applications and makes it easier for us to scale the back end independently from the front end. Behind each of the two load balancers, both the backend and the front-end applications have simple Kubernetes pods, and they are internally load balanced by what's called a Kubernetes service. The service maps every post on the pod and exposes them as a service. The Kubernetes service acts basically as a bridge and as an abstraction layer for the services to the ingress. One last point is that we have found this setup very convenient in terms of flexibility, but we also discovered that traffic, that is the load balancer and reverse proxy, is basically a single point of failure. At this point, it's pretty evident from the diagram itself, I think. So upgrading the load balancer to a newer version proved to be particularly challenging, but we have mitigated the issue by running multiple instances of the load balancer for each cluster, which is a widely adopted solution in the traffic community. And so on to the next point. So next point is 5, the build, release, and run process. I won't spend too long on these since Chris will also spend a few words on our pipelines. Every time a new version of the code is ready to be deployed, either in the test or production environment, the developers create a Git tag. Pushing the Git tag to our repository on GitLab will trigger a GitLab CI pipeline. During this pipeline, the Docker image will be built and pushed to our private Docker registry in the Google Container Registry. And during the same pipeline, an Elm image will also, an Elm chart will also be built and pushed to a private Google Cloud Storage bucket that acts as a private Elm registry. At this point, the Elm chart is available for deployment and will be shipped to the relevant Kubernetes cluster using a very simple Elm upgrade command. So these introduced very strong pipelines, and we haven't faced any real challenge when building the pipelines, which is always it's always a positive thing, I think. Next slide. On to the next point, which is also one of the most important and interesting, scaling. This is number 8 in the 12 app factor methodology. In this diagram, I've divided the components of our service into 2 factions, the ones that can scale horizontally on the left and the ones that can scale vertically on the right. In the case of Haiku, Sidekick and Redis pods, horizontal scaling is achieved using what's called an horizontal pod autoscaler in Kubernetes. Each of these applications has 1 or more pods, and Kubernetes will automatically replicate them when the load on the application is increasing. The challenge in getting the horizontal pod autoscaler to work with Haiku and Sidekick has been to actually write the Kubernetes object properly and testing them, which has taken a lot of time. Solar is also a very interesting example of horizontal scaling, since rather than scaling the pods, we have to add a new Solar node and increase the replica factor of the index to get copies of the index on the new nodes. This is something that most people running Solar Cloud are familiar with. On the right-hand side, there are the components that will only scale vertically. Some of them have a very long tradition of vertical scaling, like Postgres. Google Cloud Storage has unlimited storage, so obviously scaling is not an issue in that context. And last but not least, Kubernetes has a system called Cluster Autoscaler that will automatically add new nodes to the cluster when new pods cannot be created in the existing nodes, and that has proved to be very convenient, mostly because we basically be handled automatically by Kubernetes. Next point in our list of factors is number 11, that's logs and visibility. It's essential to have a good visibility on the performance of the cloud components. We use Google Stackdriver to log everything that happens on Google Cloud. We have a very fine-grained visibility on everything happening there in the repository, and we also have visibility of every Kubernetes pod and Kubernetes node. Looking at the numbers, we have delivered an average uptime beyond 99.99% in the last 12 months on our repository, which is something we are very happy with. Of course, the screenshot shows our Google Stackdriver monitoring dashboard. Probably it's too small to see, I guess, but there is database storage on the right and the usage of the API in the middle. Stackdriver will also register the errors happening in the application automatically, and they are presented in the box at the bottom right. In Stackdriver, the logs generated by the application are also used to create metrics and to measure performance. In the next slide, we will see how the metrics are used to trigger some alerts. So in Stackdriver, an alert is triggered if any of the values that we measure goes beyond a specific threshold. And an alert will send notifications to developers and product managers in any format. We've chosen to get them as emails and text. This is a real life screenshot. It's a screenshot that shows text that I got on my mobile from Stackdriver on the 21st of July regarding a high level of activity on the Google Cloud Storage component in our test environment. One thing to note on Stackdriver is that Stackdriver is very focused on logging the application errors, but we also use another open source service called Sentry that we can see, yes, in the next slide. So from Sentry, we get very detailed information about the errors generated by the user while using the application, and we also get information about which page or which repository work generated the error, which is very handy when trying to debug the issue. And in this context, I think it's worth mentioning that we don't store any data that can identify the user directly, but we have very useful information about what browsers he used, which operative system, and the exact point in the code where this error has been generated. This slide, this is number 11, and this slide closes our list of factors and challenges that we had to consider when running the Haiku repository in the cloud. I have a few bonus slides on other topics that prove to be particularly challenging. One of them is data input and output. When it comes to data workflows, there is a quote that I really like, and that says that an import without an export is a lie. And to this, I would also add that it is a lie and a problem if we don't guarantee data consistency. So one of the areas where we have been more focused has been the ability to import and export data to and from the repository while guaranteeing data consistency at the same time. So we created a data import application that can ingest CSVs and import metadata and files in the repository. In this process, every item in the CSV will basically be turned into a JSON and injected into the standard repository ingestion pipeline where the new work is created. The metadata and the files are then available for export using different standard interfaces, including a CSV export tool, which is currently being posted to an Haiku Hierarch plugin by Chris and the rest of the team. And there are also other data export routes like the JSON REST API or the OAI PMH feed. We are also considering Backrux as a replacement for our own import-export application. Additionally, well, last but not least, the metadata and files can be exported as an RDF straight from the cloud database and reused in a different Fedora instance if that's necessary. Next slide. In this slide, we have some screenshots of the round trip where a CSV exported through Haiku, through the Haiku interface, can be edited and re-imported using the importers tool in order to bulk update the existing records. And this picture basically closes the circle of data consistency. One other bonus slide is about localization. This is another aspect that has received much of our attention in the last few months. We know that repositories are going to be accessed by users from many countries, and providing a localized interface is one of the areas where we really trying to improve. Our front-end application has native support for localization in any language. I have to say that React.js as a front-end technology has made that very easy for us. But we also recently launched a hosted application of WebLate, that's a translation platform, and in order to help our team and customers to translate the products. We also use WebLate to sponsor the translation of IRACs. So if anyone who knows more than one language, please get in touch with me or Chris. Your contribution is always very welcome. And I think I have my last slide. That's another bonus slide on Google Cloud versus AWS. We have always run the repository on Google Cloud, and we know that Amazon offers Kubernetes infrastructure as well. I think it's called AKS, Amazon Kubernetes, AKE, Amazon Kubernetes Engine. The first reason is that, the first reason why we opted for Google Cloud is that Google invented Kubernetes in many ways. So many cloud services experts agree that Google Cloud has the most mature Kubernetes technology on the market. And the second reason is actually about data distribution. So we know how important data distribution is for a repository, and Google Cloud Storage has superior download performance compared to Amazon S3, especially for large data sets. This is also the reason why we are looking at migrating our data distribution to Google Cloud Storage in the near future. And this was my last slide. So over to Chris.
Thanks, Francesco. As Francesco has been highlighting the ways that we've made our infrastructure architecture work with 12-factor and be scalable and all those good things, I wanted to focus a little bit on how we're handling kind of code architecture and customizations. So if any of you have worked with Haiku, you know it's a kind of Samvera solution bundle built on top of Hyrax, but it is itself a Rails application. It's not just Hyrax where you have a Rails engine that you then bring into your application and put all your customizations or kind of local code in one place. And instead you have a full application, you have to make changes to that application, which sometimes can be kind of tricky to figure out a good way of doing that effectively and sustainably. So some of the customizations you might have in a Haiku instance would be adding work types, new features, customization, bug fixes, all those sorts of things. Avalon, I've worked on in the past, which is another solution bundle, has kind of the same question of how do you take it and customize it for your own instance. So approach we used within Avalon was kind of managing it via forking. And so this animated graphic here kind of shows the process. You have your upstream code, you make a fork of it, you add some new commits, you squash them, then new commits happen upstream. So to bring them in, you rebase your kind of mega commit on top of the latest from upstream. So this works. It can be a bit cumbersome and make for some, even when squashing, it still can make for some really gnarly rebases. But it works, and all of your stuff is there together for better or worse. So a different approach that we're trying out is kind of trying to manage all these customizations via plugins. So you have upstream here on the left, and then each of the plugins will basically just have their own commit that updates, refreshes, adds support for the latest upstream that is building upon. So it kind of separates out the timelines and release schedules to make it a little bit more or less entangled. The code is separated into separate plugins, and things can kind of flow a little bit more organically. So what does this look like within our Haiku context? I should say this is something we're trying out with kind of our new work as part of the Advanced in Haiku project to take a look at the Ubiquity Press Haiku repository and upgrading it to a newer version of Haiku, and how to bring over our customizations in a way that makes them more usable by the community and makes it kind of the same sort of 12 factor stuff, maybe of being more agile, being more composable and scalable. So this is kind of what it looks like. We have Haiku as our kind of like our trunk of our tree. We have our plugins that are kind of like these big branches. And then we're looking at having kind of one monolithic plugin that kind of is specific to a particular application that just does all of the customizations that are necessary, overriding anything that was added below. So as I said, this gives us more flexibility of being able to kind of independently version these different customizations as plugins, kind of composing them out and hopefully making them usable by the community. And hopefully makes us a little bit faster at being able to integrate stuff from upstream Haiku by just being able to layer our stuff back on top and upgrade each plugin kind of as we need to. And keeping us closer to trunk Haiku should make it a lot easier for us to contribute back and do that often and easily. So what does this look like in an all plugin approach to kind of the deploy process? This is a screenshot of our GitLab pipeline, and it just has a few steps here, which Francesco kind of showed in a previous slide, but it pulls down Helm chart templates, clones Haiku from the default branch. Nothing special there, just straight upstream Haiku. Then it has a step adding plugins, which is just injecting our plugin gems into the gem file, bundle install, running any generators for those plugins that are necessary, and then copying over any kind of configuration that's captured in initializers or environment config that's not already kind of on by default within those plugins. Then there's a step that builds the Docker image, pushes it to our container registry, and then final step packaging the Helm charts and shipping those off as well. And so that's our process of kind of taking the kind of default, trunk upstream Haiku and layering all of our customizations on top of it to build our final application and get it ready for deploy. That's all from me, and I just wanted to take a moment to thank our whole repositories team who have built out this product over the years and continue to work on its maintenance. So I think with that, we're open for questions. Thank you.
Excellent. Thanks to you both. So we have about 2 minutes for questions. One that came in via the Q&A is, how does Google KE compare to Amazon EKS in terms of cost?
That's a very good question. I believe that costs are pretty much at the same level between the two. Well, to be honest, I haven't checked them in the last couple of months. But at least in our scenario, cost is, well, we know how important it is to deliver a cost-effective solution, but I don't see much difference in cost between the two, rather than a slight difference in the type of service rather than the cost itself.
All right, we might have time for one more question. Otherwise, thank you both very much. And it is time for our next presenters.
Afternoon, I think that's me.
Yes, we can hear you, Richard.
Lovely.
You're a little soft, but.
Hang on, I can put my headset on. Maybe that makes sense. Okay, how's that? Is that better?
Yes, thank you.
Perfect. Afternoon, everyone. Right, bear with me while I do the screen sharing bit. Okay. So yes, good afternoon, good morning, good evening, wherever it is you are in the world. Thank you for coming. My name's Richards, and I am going to be talking to you today about our SWORD 3 project, which is a deposit protocol. We have been going through a process to produce this third version of the specification for, well, it's quite a long time now, about 18 months, coming up on 2 years probably. So I'm going to tell you a little bit about SWORD and about what the third version of SWORD is all about, and why you should be interested in it, and what we've been doing over the last couple of years in getting us to this new version. Usually when I do presentations and I'm in the room with everyone, I ask for shows of hands to see who has heard of SWORD, and or who's looking for more information, which is kind of difficult to do in this format. So I'm going to kind of assume that you have heard of it, and I'm going to try and tell you as much as is feasible in the time that we've got. But of course, feel free to add questions to the Q&A in the chat, and we'll deal with them at the end. So let me give you a little bit of a history of the project. It's actually been around for quite a long time now. The first version of SWORD was released way back in 2008, and it was a first attempt to kind of standardize one of the key use cases that we have in the repository world, which is how do we get stuff into them. And so the first version of SWORD was very, very simple and focused around that specific use case, which we came to know as fire and forget. So you would bundle up your content, you'd throw it at the SWORD server, and you'd walk away. And after what happened to the content after that was down to the repository, and you had no further real interaction with it. And that was a good starter. It was built on AtomPub protocol, which was kind of relevant at the time, and was kind of gaining some popularity for publishing or pushing content around the web. But it soon became quite apparent that for more advanced repository use cases and repository integrations, we were going to need a little bit more than fire and forget. So quite soon after we released the first version, we started to look into what a second version that had a broader treatment of CRUDs, the create, retrieve, update, delete kind of life cycle that you would see on a kind of storage endpoint, if you like. So we started to look at the repository in terms of being able to provide storage and content management services for other scholarly systems. The most obvious use case that we really focused on back then was CRIS systems. So a lot of CRIS systems were wanting to do repository integrations, but they were managing all of the metadata through their front ends, and they were providing nice interfaces for their end users. So they were looking for a way to allow content from the CRIS to be synchronized to the repository, or to allow the repository to act as the kind of the file store and version of record for the content that they were displaying through the researcher-focused user interfaces that they were building. And so in 2011, we released version 2 of the specification, and that contained this kind of full set of content management capabilities. So you could make new objects, and then you could commit updates to those objects, and you could delete things from those objects. And that was done by a simple extension to version 1. So it all remained, the technology all remained the same, and it was just additional capabilities added to it. We then took a very long break, as you can see, 9 years in the intervening period. Actually, the work for SWORD 3 started in probably 2012, 2013, the very first ideas that we would probably want to do another revision, as people started to look into how repositories were going to work with research data. But for various reasons, that process moved very slowly. And indeed, we'll talk about why that is a little bit later on in the presentation. But eventually in 2018, we got some funding to look at how we can start to support the research data use cases that the community is now starting to face. And when we did that, at the very beginning, we thought, well, we're we're bringing the specification up to date for modern use cases. We ought really to bring it up to date with modern technology as well. And so the old version of Sword, as I said, was built on Atom Pub, and it was kind of REST, but it kind of played a little bit fast and loose with the REST principles. So we decided let's move to JSON LD actually specifically, and to really focus on being adherent to the principles of REST, and to build a protocol that was much more modern. So version 3, which is in its final release candidate now, does all of those things. And what I'll do is I'll tell you a little bit more about what those things are and how they relate to what Sword 2 used to do. So first of all, I just want to quickly give you some motivations to this. I'm not going to, by the way, I'm not going to get into technically what Sword 2 actually Sword 3 actually looks like. I'm not going to show you any code snippets or anything like that. I don't think there's, time in this kind of presentation to do that. If anyone is interested, at the end, there's a lot of links to the specification and the code that we've written, and you can certainly go and explore that or come and talk to me about it afterwards. So I'm just going to focus here on the higher level kind of understanding as to what it is we're trying to achieve with Sword. And so these are the kind of key use cases that we're interested in. Research data deposit is the primary driving factor here. That's what kicked off this whole third round of work. And then under that heading, we're looking at transmission of data, meeting good metadata standards. So it's not just about throwing arbitrary files around, it's about moving structured content with the metadata standards that we've come to expect in our community. It's about supporting machine-to-machine deposit. As research data becomes a thing, we might be looking for the machines that produce the data to being able to put that content straight into a Sword-enabled repository. So we need to minimize the human involvement wherever possible. There were use cases around being a man-in-the-middle broker, so accepting content and then distributing that content to various other locations. Acting as real-time file storage, which is quite similar to the Chris use case that I talked about for Sword 2. Being able to monitor workflow progress. What's the state of a thing inside the Sword server? Do I need to take action? Is action being taken on it, etc.? And we also wanted to, as part of the research data deposit theme, be able to support arbitrarily large files. So no matter how big the thing you need to deposit, we want Sword to be able to have the mechanics for you to deal with that. And also to be able to send files by reference. If you're storing files in specialist storage systems for the kind of data that you're working with, and maybe it's not appropriate to send that to the repository, we want to be able to put those in and either maintain a reference to them or dereference them as needed. So there's a link on the page here. This presentation is in the shed, so if you want to download it, I believe it's there. Otherwise, I can send it out if that's necessary. So you should be able to get at all these links in due course. So let me tell you what we did functionally to Sword 3 in addition to what Sword 2 already did to kind of support these use cases. One of the kind of first things we did was we added concurrency control, which is something that Sword 2 didn't have. So by using the standard HTTP approach to concurrency control, which they call optimistic concurrency control, the idea is to avoid unintentional data overwrites, and that comes from the theory or the ethos that Sword 3 will allow repeated actions on an object, so adding more data to it or modifying the data that's in it, and that may come from a variety of different sources. If you have a machine inserting data and a user inserting metadata, then you don't want those two depositors to clash or step on each other's toes. So concurrency controls gives us the ability to at least protect against unintentional data overwrites. We've also added a lot more support around metadata formats. Sword 2 allowed you to do whatever you wanted with metadata, but it didn't give you the semantics to describe what you were doing. And so Sword 3 now does that, so that you can move metadata around in a variety of formats, and you can explicitly declare what it is that you're doing. So you can confirm support with the servers that host the content. We've implemented segmented file upload, and it's implemented very similarly to how you would see it out in the wild. So we confirmed that our approach is pretty similar to, say, Amazon's approach to handling segmented file upload, and that means just being able to chunk large files into smaller chunks and then send them. the mechanisms behind supporting that. And that supports the idea of multiplex as well. So if you've got several machines that you want to upload the content in parallel, then the segmented file upload mechanism can handle that. And then finally, some explicit support for by reference deposit. So those are the four main things that we added, and for the most part, they then give us the power we need to handle the research data use cases. So the differences then from SWORD 2, for those of you that are familiar with SWORD 2, we'll see. First of all, it's JSON, not XML, and specifically we're using JSON LD, so that it sits nicely with the kind of semantic web or linked data community. We've made a lot of terminology changes, and SWORD has often fallen back to kind of banking analogies, deposits and statements and things like this. And we've decided to kind of dispense with all of those kind of analogies because they start to break down and they start to become confusing. So now it's a little bit more bland in its language, but we hope what that means is a little bit more easier to understand. We've also merged a few of the document types. This is one of the areas where SWORD 2 was really deviating from REST, is that it had a specific response format that you always got back, irrespective of what you'd done, and another document format that represented the type of the object. Those two things have been merged into one, so you can always see a consistent description of the object, and at the same time we then strictly adhere to the REST principles, so you only get that document back in the right context. We've merged the concepts of services and collections. Originally, SWORD 2 had this thing called a service document, which was your way into the SWORD endpoint of the repository. You'd hit for the service document, and that would then tell you what you could do. And one of the things it could tell you is that there are all these collections that you could deposit into. Those two different concepts have now gone, and there is simply the concept of a service, and a service may or may not be nested inside other services. So it simplifies the structure a little bit, and it gives a bit more consistency to how you interact with a service. As I mentioned in an earlier slide, we've got now a more formal metadata support. Version 2 of SWORD allowed you to put whatever metadata you wanted into an atom entry document, which is an XML document. In version 3, there's a typo on my slide. In version 3, you can put whatever metadata you want in whatever format. So if you've got it in XML, or you've got it in JSON, or you have it in some format of RDF, as long as the server tells you that it supports that format, then you can deposit content in that format. We've added concurrency control. We've added by reference deposit, as I previously mentioned. We've also added, after quite a lot of pressure, a native packaging format. So SWORD, I've always maintained that SWORD is a transport protocol. It is a transport protocol. And so we've tried to avoid saying too much about what content gets transferred over that protocol. In the same way as you wouldn't expect HTTP to say too much about, or indeed anything at all, about what your HTML looks like. Nonetheless, as an integration protocol, the language with which the services talk to each other is important, but what it is that they're talking about is also important. And we have tried to restrain ourselves from saying too much about that. But in this version of the specification, we have identified a packaging format that is based on Bagit, that it has parity with the metadata formatting and the individual file transfer processes that SWORD 3 also implements. So there is a packaging format now that is kind of the SWORD standard packaging format, and it's as bland as we could make it while also being feature complete. So now anything that you can do by individual operations over the REST endpoint can also be done by sending a package that contains the equivalent content. We have then implemented segmented file upload, as I said. And for those of you that really do know about SWORD 2, and I have no idea how many of you out there that will be, multi-part deposit has gone. There was a feature of SWORD 2 which allowed you to send both the metadata and file content in a single deposit. It was built on an AtomPub extension. That AtomPub extension was not particularly widely used, and the toolchain support for multi-part deposit was terrible. So I don't think we ever saw a successful implementation. So we've just dropped that concept. And the native package format that I mentioned above kind of does away with the need for any kind of complicated multi-part MIME messaging over HTTP there. So that's all gone. We've also added lots and lots of little things that were bugging us from the old version of the specification. Better use of redirects, better errors, more specific errors, and there's more of them, so you can be more accurate about what went wrong. Better semantics in general, and we've also removed content negotiation, which sounds bad, but actually in reality, content negotiation wasn't particularly widely used in the older versions of Sword, and it added complexity to how the specification was implemented. So Sword 3 doesn't have content negotiation as part of the specification, but it does have a mechanism by which you can discover content in a variety of different forms. So instead of negotiating for the metadata in one format or another, Sword 3 simply allows the server to list the endpoints for the metadata that's available with its various properties, and then the client can choose which one of those to retrieve. So we're simply removing HTTP content negotiation, but not the content itself. And there's a short document there, Sword 3 new features, on our GitHub that you can read that'll go into each one of these changes in a little bit more detail. So what have we been doing then in terms of implementation? So everything I just said there came from the work that we did on the specification, and that took place over a year in consultation with lots of people from the community, including people from the Samvera community. In October last year, we started an implementation project. What we wanted to do was make sure that we could implement the specification before telling anyone that the specification was complete. And we chose to do that in Python against Invenio, so the competition. And that was funded by NII in Japan. They gave us a pot of money to produce both the client and the server, at least in part because NII are Invenio users, and they have historically an interest in Sword. They've been involved in the Sword specification since the second version at least. So we may well see that in production in Japan at some point. So out of that work, we produced a number of kind of key things. First of all, we produced a common library in Python, one that understands all of the document types and all the various different semantics of Sword more generally. Then we produced a client library, again in Python, and that wraps the common library and just provided you with all the kind of on-the-wire operations. So if you want to create a new object, there's a function for creating a new object, and it'll guide you through the process of sending the right data to the server. But the meat of the work was then in this Invenio reference implementation, and this, a basic Sword implementation is not too difficult. Receive some content, put it in the repository, extract some metadata. The normal kind of repository fare. But what we really wanted to test was the more advanced features like segmented upload, which is quite difficult, and it involves various different kind of concurrency issues or race conditions that you have to deal with. When do you do certain operations? When do you do unpackaging operations if an object can still be edited by the user, etc., etc. So we spent quite a lot of time exploring what the complexities around implementing the more advanced research data features are, and we've produced a server library for Invenio that can then be used to demonstrate the specification is implementable. It also produced quite a lot of feedback. As we went, we discovered these oddities, and we thought, well, this is complicated to do in a repository. Maybe we can change the specification in a way that makes this simpler to look at, or maybe we can add advice to the specification to help users decide how to implement against their repository. And in fact, and there's a link at the end of the presentation, in the end, we produced a short document called Developer Considerations, which outline the kinds of things you need to look out for if you're implementing the server side of a Sword 3 interface. So that feedback all came back into the project, and then we produced a final release candidate of the specification, which is currently out, and you're very welcome to read it and also give feedback. Technically speaking, we haven't made the final release of the spec yet, but unless anyone gives us any feedback, we expect to simply release the current release candidate as the final version of the spec. So then I want to talk to you, and the reason that we're here, you know, I mean, it's very clear that we haven't done any Samvera work, and yet here we are at Samvera Connect telling you about this. This is because for us, what's next is to engage the repository communities more broadly. You know, as a company at Cottage Labs, we've got engagement in a variety of the communities we work with Invenio and Samvera and with DSpace. And so we would like to see the Samvera community kind of getting engaged in SWORD 3. We've already had that in terms of the specification. We had Samvera community members giving us input on the specification itself. But we'd love to see an implementation in Samvera. So, you know, we're out here looking for support or interest in SWORD 3 in the Samvera software stack. You know, and that could be kind of generally kind of central, you know, interest just because for Samvera, or anyone out there who has projects where, you know, oh, it's SWORD 3 actually looks like that might be a fit for our project, and we're using Samvera, you know, either to come and talk to us or to get involved in SWORD 3 to help make it part of this community. So, you know, there's a couple of options we're kind of exploring, you know, in terms of funding. So either, you know, if there was a group of people within the Samvera community who were very interested in this and you wanted to do an implementation, then we'd be very excited about that, and we'd be able to talk to you and, you know, help you out with the implementation. Or if we can secure some funding, which is something we're trying to do, then it's possible that we'll be able to put together a team that can do an implementation for Samvera, and ideally a general client library in Ruby would be good. You know, so we have some Samvera skill in house, but it would be good to involve other people in that project as well. So I kind of, you know, in bold there on the screen, if you are interested in SWORD 3 or in any Samvera or related environment, then come and talk to us and we'll see if there's something that we can achieve together. So that's on the technology front. There is also a community front to SWORD, which is, it's quite challenging and it's quite interesting. And I haven't put too much emphasis on it in this presentation because my colleague Neil is in charge of this side of the project, and he's not here, and he's the guy who knows more than I do about this. But essentially, we're looking for a home for SWORD 3 in the longer term. It's kind of it's sort of informally lived at JISC since 2008, who are that JISC are infrastructure funder in the UK. You know, and it's had a little bit of input from NII and a little bit of input from EBSCO. But it's not found itself like a true home. And one of the problems with for SWORD in our communities, and the repository community more generally, is that we're really good at finding homes for software. You know, we have great communities for looking after our software, but specifications have a less obvious place. So we've got a number of options that we're pursuing, and I can't really talk in detail about them yet because they're all quite in early stages, and we don't really have any concrete outcomes. But we are interested if anyone out there has an urge to, you know, put their organization forward as a possible home for SWORD 3 as a specification rather than a piece of software, or if you have an idea of someone that we could talk to, then we'd be very interested in that, and we hope that we'll be able to find a place for it so that it can, you know, go on to SWORD 4 and SWORD 5 as needed by the changing requirements of our community and of our technology. So let me finish here by just giving you a long list of links, all of which you will be able to get hold of by downloading the presentation from the shed. There's obviously the specification. There is a document called Behaviors, which is the specification but spelled out play by play everything that you might want to do with SWORD. So that's an implementer's guide essentially. There's the beginnings of a playbook. You know, if you're looking to implement a particular use case with SWORD, we want to start filling this playbook up with strategies for doing that. So you've got a particular set of systems and a particular interaction you want. What's the right way to do that with SWORD? We have the developer considerations document, which I talked to you about earlier. And then we've got the client and the common library, both on PyPy and Read the Docs, if you want to go and read about how the software itself works. And then the Invenio reference implementation is also on Read the Docs. And I haven't given you a link to the software, but you'll find it from the documentation. So there's plenty of resources, there's plenty to look at, and we would love to add a Samvera reference implementation and our Ruby client to this list of useful documentation. So please do come and talk to us and tell us, what you want out of Sword and how we can help this community get that. And I will sign off there and ask you for questions.
Thank you, Richard. We have 5 minutes for questions. If folks have any questions, you want to put in the Q&A or the chat or on Slack. All right, hearing none.
Okay.
Thanks, Richard.
No worries. Am I right that the presentation is easily available to everyone if they've got the shed? They can just go and download it.
Yes, I'm not sure that it's in Shed. I think it is in our repository for Samvera, and also linked from our wiki for Samvera. If anyone knows anything different, they can correct me, but I believe those are the 2 places you'll be able to get it downloaded.
All right. Well, thank you very much for hosting us. Since we didn't do any work on Samvera for this project, it's much appreciated.
No worries. Always happy. All right, so I am going to put up it's time for a little intermission. We're going to go to 20 after the hour, or 1:20 p.m. Eastern. Pop that up for us. There we go. We'll see everybody back here in about 13 minutes. All right, welcome back, everyone. I want to welcome Emily and Devanshu, our next presenters.
Hi, everyone. I'll get my screen going here. Please let me know if you aren't able to see my screen. Welcome, everyone, and we're very glad to be with you. We're joining you from storm-swept Atlanta, but fortunately, Devanshu and I both had power and running water and internet and all those good things. My name is Emily Porter. I'm the repository program manager for our new Samvera-based repository here at the Emory University Libraries. And I am joined by Devanshu Matlawala, who is representing our software engineering team. And today we're going to talk a bit about our experiences building a second generation repository using Samvera components. This includes our approach to defining and managing preservation entities. We'll talk about our implementation goals and some specific examples and challenges that we've worked through. And we have probably a little more material than time. If we do have time, we'd like to talk about some of our other preservation surface components and some self-assessment activities that we've done. And I also want to note, I realize not all of you may have these kinds of use cases that you're looking at, but we hope that you'll still find this interesting and informative. So before we began development on our next generation repository, we had a very lengthy requirements gathering process. We had a digital preservation requirements working group that reviewed a number of very large and well-established standards. I don't have time to talk about all of those, but I would mention some key references are the OIAS model, Premise Metadata Standard, Portland Common Data Model, Library of Congress preservation event types, and also while we were going through this requirements activity, the libraries also implemented their first comprehensive preservation policy, which in and of itself was a pretty big deliverable for us. Previously, a lot of our preservation activities were kind of happening in silos across the organization. So looking at our actual implementation goals, one was to really actualize and realize that preservation policy and put it into practice and into code. Building our locally defined archival information package structure, so what digital objects for preservation would look like and how they're structured. Leveraging existing Fedora 4 capabilities, working within our institution's AWS and S3 capabilities. And these last 2 points are really critical, I think, for HIRAX specifically, was being able to provide a human readable audit trail of significant activities that are occurring on our assets, and to manage as many preservation activities as possible through a HIRAX-based interface. So here's a quick overview of our local infrastructure. We're hosted in an Emory University managed AWS environment. And I point that out just because not all of the full service catalog from AWS is available for us to use. So in some cases, we had to get a little creative. Starting from the top here, we have a Blacklight discovery and access interface. Won't really be talking about that today. We also have a HIRAX 3 based application, which I am very sorry and send my apologies and compliments to Notre Dame. We didn't mean to steal your product name. We have been referring to this as our library staff curation and management application, and it kind of just got whittled down to DLP curate. We use Solar Cloud for indexing, Fedora 4 as our sort of system of record for preservation metadata. We don't store our binaries in Fedora 4, but instead push them through into S3. And I'll talk a little bit about our storage later on. So one of the first things we did was to really look at our preservation data model. And for those of you who are familiar with HIRAX and PCDM, this should look fairly familiar to you. However, we've had to make some additions to this. So we have a single generic work type and a comprehensive metadata profile at the work level. Works contain descriptive rights and administrative metadata, and they also can hold these child entities for preservation workflows and for events. And we'll talk about each of those in more detail. At the file set level, file sets perform the typical hierarchs function. They have a little bit of descriptive metadata. We've expanded on that slightly. And then they also can contain event objects. And then within the file set, we have expanded on the number and types of files that a file set can contain. So that includes a preservation main file, as well as intermediate, service, extracted text, and transcript. And so we'll talk a little bit more about this in detail. So in looking at our file set extensions, before I go any further, I do want to call out some harmful language. The phrase preservation master file. Unfortunately, this is a fairly well established term in the preservation community. And I would love to talk to others of you who are in that community or other communities to see if we can find a better term. But you will see that in our code and in our interface, unfortunately, and I do apologize for that. Some of this nomenclature is coming from the PCBM use extension. If you aren't familiar with that, there's a link there. At the file set level, we also provide support for primary and supplemental content. So some file sets are intended for users to interact with, and others are more serving just purely a preservation purpose. And then we do extract a couple of additional technical metadata fields from FITS beyond kind of what's standard for hierarchs. And at the right side of my screen, I am showing an example of a book object file set. We've really heavily customized the view file set page, but you can see all the populated files for this particular file set includes a TIFF and an OCR file and also a plain text output. And we've also added a couple of utilities here to run fixity checking on demand. We'll talk more about fixity checking later if we have time. We also have some utilities to regenerate the thumbnail as well as recharacterize the file set. And then we display all the available technical metadata there for the set. In terms of how file sets are created, we have two methods. One is a bulk import process using CSV files, which DCE developed for us. At the top of my screen, hopefully you can see there is one row for a work, and then there are additional rows for each file set. And that provides that kind of file context mapping within the file set. And then these are all related back to each other by use of a deduplication key, which we determine kind of for each work and relative to a collection. And then we also have modified our edit work form. So the files tab there has been replaced with our own form that allows users to supply that main preservation file as well as any additional derivatives. Oh, sorry. And now I'm going to hand it over to Devanshu to talk a little bit about some of the implementation in code.
Thanks, Emily. So to make this possible, we had to make some changes to hierarchs, basic hierarchs out of the box. Some code changes that we made were around the ingest jobs, like the attach files to work job, and also the database schema. We had to add columns to a database table to be able to save the additional files that we wanted to save in a file set. So basically with hierarchs out of the box, we get 3 files for a file set. One is the original file, then the thumbnail and the extracted text. The thumbnail and the extracted text are created during the create derivatives job. In our curate application, we needed those 3 plus 5 additional files per file set. Here we have our own extracted text that we use. We have a custom predicate for that, and that gives us the ability to upload our own extracted text in case of books. And we also switched off the automated extraction, text extraction that happens via hierarchs. Also, we made some changes in the file actor, the ingest file method. We were making sure that during characterization, when we run or queue up the characterized job, we make sure that we only queue it up for the preservation master file and none of the other files in the file set. So just checking when the file is ingested, if it's the preservation master file, then you queue up the characterized job. Uh, to also, we had this logic in place that when we were creating derivatives, in our case, only thumbnail, we were making sure that we create a thumbnail for a preferred file, that logic that we had, which was basically if the service file is present, then you create a thumbnail for the service file, and if not, the intermediate file, and finally, if none of those are present, then the preservation master file, which is a required file in the file set. We also use this logic to display the file or the image in the universal viewer display. And we used the preferred file logic to make sure that the correct image URL is going into the IIIF manifest, which finally is being used by UV. There's a lot of changes that we have made to the curate ingest process, to the hierarchs ingest process in curate, and we've linked our changes. We have made a documentation, and the documentation is linked on this slide.
Thanks, Devanshu. So next, we're going to talk about those preservation event entities. And we define those as primarily automated system actions that occur to some type of larger workflow. And each of these actions are captured in a human readable event entry. So the events that we're supporting in our first version at the work level include policy assignment. And this is where we record the initial visibility that was assigned at the time of ingest. Validation provides information about the ingest into Fedora for the work, and that all the required components were supplied. And we also have a generic modification event that just kind of tracks basic information about when a work was modified after ingest. And at the file set level, we're tracking a number of events, including virus scanning, characterization, which includes a number of actions that FITS performs, message digest calculation, in which we calculate one or more checksums depending on the file submission, and that's recording when the file was submitted out to preservation storage, and also fixity checking. So here is kind of a view of, this is also part of our view file set page. This is an example of the events that we're recording for a file set. We have used a local namespace to define these, but you will probably see some similarities, kind of premise-ish, but not really. And in the example of a fixity check event, you can see the name of the event, the start and end, the outcome, whether it was success or failure. And then we have event-specific detail, in this case, the individual file that was checked and which checksum was being verified. We also capture the initiating user, and you can see my little sarcastic name tag there. Hello, my name is bypass admin. We had to do a bit of work to actually detect and record who or what the user was who initiated the process. So we're glad to have that working. If you look at these things in Fedora, a lot of times it just comes through as this kind of generic bypass admin user. And then we also record the name and version of the application that was performing the task. And I'll hand it back over to Devanshu.
Thanks, Emily. Talking about the implementation details of preservation events, we had to split out events. Some were being saved on the work, while some were being saved on the file sets, and some on the files. So for the work events, when a work is saved, we would create an event like validation or policy assignment once the work is created, and save those events on the work at the work level. Some events like the file set events were that Emily mentioned before were something like file submission. So when a file is submitted or ingested, we check if the file was saved correctly or successfully, and then accordingly we have a success or failure event. Some of the file set events were saved on the file set level, meaning only for the preservation master file. For something like characterization, like I mentioned before, we only characterize the preservation master file, and message digest calculation only happens on the preservation master file. So those are saved only once at the file set level. But something like a file submission or a fixity check that happens for every file in the file set, so those are more in number as compared to characterization in terms of on a file set. These preservation events are implemented as nested objects in Fedora. A preservation event has its own model class in code, and we use nested attributes on the work and file set models to be able to implement preservation events in those places. These events are also indexed in Solr for display purposes, so that we can retrieve index data quickly and show them on the work show page and the file set show page. There's more documentation on preservation events again in our GitHub, and which is linked over here on the slide. And hopefully, when these slides are shared, everyone can take a look.
Thanks, Devanshu. So next we'll talk about preservation workflow entities. And we define these as much more human managed, but also human readable context for major digital object lifecycle phases, and particularly including any associated rights determinations. So some examples of these would be accession. And this is really largely upstream of the repository, but it is information that's very important for the long-term custody of the item. So why did we decide to digitize or make a copy or preserve the item? Ingest, so circumstances around the actual ingest, particularly if it was a migration type situation. Versioning, I have an asterisk here because we still have a lot of work to do on versioning, but that's something that we hope to address later. Decommissioning, circumstances of if we had to remove or reduce access to material, and deletion. And I wanted to note also that our preservation policy, really, we don't delete. Except under very rare circumstances. So that's another aspect of the Hyrax user interface that we've had to do a lot of work on, was to suppress those very readily available red delete buttons and only allow certain administrative users to do that. So our workflow metadata, this again is defined in a local namespace. We record the name of the workflow, some general notes about the workflow, and then we have a number of kind of rights related information for that determination or for that lifecycle event. And you can see on the right here is an example of an object from our repository that has quite a bit of this populated. There's some information about the original donor, and also the ingest. So kind of, this is a public domain object. So we've recorded that relative to those determinations. And then this object was actually slated for decommission. So the physical object is not necessarily going to be provided anymore. And therefore the library administration requested that we suppress display of that particular item. And I'll hand it back to Devanshu.
So the implementation for preservation workflow is similar to preservation events. Workflows are also nested objects, but they are only saved or they're only saved as nested attributes on the work model and not on file sets. Like events, these are also indexed in Solr for display purposes. The preservation workflow metadata is loaded after the works are ingested. We have a rake task, which is linked on this slide again. We have a rake task that takes care of adding or importing that metadata to works. We, like Emily mentioned, we really don't want to delete any of the metadata that we import. So these should only be populated once. And if there is a mistake, then we make sure that we first delete the existing metadata and overwrite on those attributes. Like I said before, these are single valued. These attributes are all single valued, and like you can see in the code, they're all multiple false.
Okay, thanks, Devanshu. So next we'll talk a little bit about our storage backup and restoration, which is obviously a critical piece to preservation context. For our content storage, we first transfer all material up to our AWS space to an EFS volume, and we perform fixity checking during that file transfer process using rclone. The first copy of our ingested files is stored in S3 in the US East region, and then we've developed a custom process using an Ansible role to identify only those newly added files in the first bucket and copy those over to a second bucket in the US West region for better geographic diversity. And that happens every 48 hours. So I want to mention just a couple of headaches. We really ran into some issues because when we first set this up, we had versioning enabled on our S3 bucket and found that that was really not compatible. And we had to go through a couple of tries to get that second copy process working the way we wanted. So I want to thank Michael Klein and also Beth Sadler and DCE for helping us get through some of those Fedora and S3 hiccups. In terms of backup and restoration, given the kind of number of components and where all the data is in a Samvera solution, we kind of had to learn the best way to identify and back up those various pieces. We did a large-scale backup and restoration activity of cloning our production data back to a test environment. And that went really well. But one thing that we learned, we were surprised by, is there's this very nice audit trail kind of that comes out of the box from Hyrax about user activity on file sets. And we learned that that's actually stored in Redis. We didn't know that. So we learned that we had to back that up too in order to be able to keep that. So finally, I will talk about fixity checking. I'm sure we could spend an hour talking just about this, and I'm sure many of you have lots of stories to share. We are using Fedora 4's fixity service. We're checking all the files in a file set using their SHA-1 values. We do have that on-demand checking offering. We also have a rake task that runs every 2 months, and that creates a queue of files that have not received a check within the last 90 days. That's working so far, but the more files we have, we know that we're going to have to adjust this just in order for things to actually complete. So all of those outcomes are logged as preservation events. We're also interested in this serverless fixity service that AWS offers, but we really don't have a sense of how much it will cost us to run that. So if anyone's using that, we'd love to hear from you. So some lessons learned. In Hyrax, those notifications about failures are only sent to the original depositor. So that's not terribly useful for us. We want to get that more in an aggregated way. We also had a recent experience with really learning a lesson about we sent way too many fixity checks too quickly to S3, and we hit some kind of request threshold, which kind of caused this tidal wave of failures, unfortunately. We also know that they are false failures, but we're going to have to kind of resolve that. The way that we kind of got past this issue was we rebuilt that rake task so that it's only running on a single queue, fixity queue in Sidekick with a single thread. So it checks one file at a time. So it runs more slowly, but we've had virtually no failures that way. Another thing, I guess, that we have benefited from doing that fixity checking is in some cases, most recently, we found about 30 file sets for which one or more of the files didn't exist in S3. So because the file could not be retrieved through this process, we learned that it actually hadn't been ingested, so we can go back and fix those. And then I'll just mention quickly another aspect of our kind of preservation service is that we want to do reporting to stakeholders, and we manually compile data from a number of sources to kind of produce this report. Some of this we can get from Hyrax, but because we have more files than the traditional file set expects, we created a new rake task that will count the number of works, file sets, and all the individual files on a per collection basis. So that's been really helpful. We also pull certain metrics from AWS. We have a CloudWash dashboard, and that lets us monitor the binary file counts and storage usage very easily. And then also for fixity checking, we're reporting on failures. And again, we're kind of compiling that from what we hear from Hyrax, also if we have failed jobs in Sidekick. And then fortunately, because we have all these events indexed in Solr, it's much easier to produce a report there. And then finally, just to wrap up, as we were nearing the end of development on this first leg of the journey, we decided to kind of take a minute and do a self-assessment. And there's a very helpful tool, the National Digital Stewardship Alliance, I believe, NDSA Level of Digital Preservation Assessment tool. So we worked through that. And largely, we're doing fairly well. There are some gaps that we're very aware of, and these are also planned features that we hope to develop in the future. One of which is making sure that we have 3 or more copies and are sending them out to preservation services or partners, including AP Trust. We also need to come up with a mechanism for how to do fixity checking on all these additional copies, because Hyrax and Fedora are not immediately aware that those exist. And then, of course, we're very interested in doing more work on versioning, both at the work level as well as at the file set level. So unfortunately, the customizations we've made for file sets means that the Hyrax kind of versions option doesn't actually function for us right now. And of course, we're very interested in utilizing OCFL and hopefully working with Fedora 6 in the future. So thank you all very much for your time. I want to thank some of our local groups, Digital Preservation Requirements Group, our software engineering and middleware teams, DCE, both current and alumni, and many of you in Samvera who have helped us along the way with consultations and also with sharing your code. So here's a link to our DLP Curate repository and also our program wiki, which has a lot more information about some of the things I've been talking about today. And then of course, Devanshu and I and many others of our team are on Slack and would love to talk to you more if we have time.
Thank you, Emily and Devanshu. That was great. We have about 4 minutes for questions. And we have one question in the Q&A. How many works do you have in your repository, and are you seeing any performance issues with these robust file sets and recording events?
Yeah, we have, at the moment, we have about 13,000 works, about 65,000 file sets, and about 160,000 files. But just for the first few collections we're doing, we're going to hit 1 million files very quickly. I would say we have not had so much problem about files and file sets so much as we've had the kind of known struggles around large community, large collections and collection membership. So we're still kind of working through that. I would say it's more at the work level than the file level.
Excellent. Another question, did you consider using S3 cross-region replication policy instead of the custom Ansible role for copying to US West?
I think others on our team might be able to answer that better than me, but I think that's one of the reasons why we had versioning enabled in our S3 bucket, and that was causing conflicts with Fedora. So someone else can probably address that in Slack. Yeah, Collins addressed that in Slack.
And I'll just repeat for the recording that Collins says that, yes, that requires versioning, and versioning did not work well for us. Any other questions? Well, if not, thank you both very much. All right, and with that presentation, this concludes Samvera Connect 2020. And on behalf of the program committee and the community building team and the Samvera helpers, all of the presenters, thank you so much for joining us and for asking great questions and for engaging in the Slack channel. And please don't hesitate to reach out to anyone that you have heard from this week and last week on Slack or via the samvera.org website or via email. If we can help you determine any other ways you can get involved in the community, we would love to help. So have a great rest of your week.